Seeking English S.A.T. Workbook, page 470, problem 1, no calculator. And I cannot see a way to use a calculator on this problem. It says, if 4x minus 6y equals 8, what is the value of 9 to the x over 27 to the y? And you can see your answers are all, okay, base 3 integer exponent. Okay, that's potentially convenient, and to some number of students, again, it would be obvious. It's obvious to me. Yeah, I'll find a problem that's not obvious to you. I'll get there. 9 is an exponent of 3. 27 is an exponent of 3, and so thus, whatever this is also an exponent of 3. This is also an exponent of 3. So exponent of 3 over exponent of 3. What am I going to do? Can I solve for x or y? No, I can't. No, I can't. But the fact that they give you these 4 answers to choose from means there's not really any give or take between x or y in terms of the answer you're going to get out of them. Think about it for a second. Okay? Means that if you plug something in for x or for y, you're going to still get one of these 4 answers, and it should be the same answer every single time. Really? Yeah. Look at it again. Look at it again. This is an important tip for many problems. Okay. What am I going to do about that x and y? They could be offsetting. If this x goes up, that y goes. It doesn't. No. Because of the design of the problem, you can be assured that whatever you put in for x, the y that corresponds to that is going to produce one of these answers. And if you change the x or you change the y, and you adjust for that, you put it in, it's going to produce the same one of these 4 answers. So you can probably put in anything you want. Let's put in pi. No, let's not put in pi. Pi's not your worst enemy on the test. 51 is probably your worst enemy. Well, what was until you learned in earlier videos what to do about number 51. Your best friend on the test is the number 0. So if you plugged in 0 for x or for y, it would stuff would start to go away. Would it break the problem? It would not. It would not break the formula. It would not break the relationship between the answers and the material that you use to get the answers. So the question is, what do I want to plug in? Where do I want to plug in 0? Well, this is a hint. The y in the denominator is a hint. I might make a second video where I plug in 0 for x and show you that it's more longer and more complicated. But this is a solid invitation to just erase the entire numerator, the entire denominator. It'll go down to 1. The invisible numerator that goes down forever. It'll go down to 1 if you plug in 0 for y. What happens up here though if we plug in 0 for y? You could simplify this equation before you plug in the 0, but some fraction of a second of extra work would be saved if you didn't simplify until you had already plugged in the 0. Okay, if you plug in the 0 there, okay, you now have 4x equals 8. That is very easy to simplify. You divide by 4. Okay, 2. X equals 2 is your simplification if you assume that y equals 0. You assume as y equals 0 here. 27 to the 0, okay, is 1, which is going to be the invisible denominator. There it goes down. It disappears. 9 squared. Okay. X equals 2. 9 squared is 81. If you want to break it down further, you can do it like this. Okay, your first-year algebra teacher will love this. It's a 3, and a 3, and a 3, and a 3. That is 4 3s. And that is your answer. And I may or may not wait for any kind of response before I make the other video to show you that it is slightly longer if you plug in 0 for x. Or you can plug in other things and you're going to get the same answer. But this is the fast way. So if you use this, what I showed you, as a model for similar problems, you're more likely to do it in a slightly faster way. And whether it's a better answer or not, it's probably about the same. But the idea here is this was the shortcut. I showed you the shortcut one time. You can apply the same shortcut to many other problems if they're similar enough. Please, 0.